Amongst the array of fascinating parks across the United States, Yellowstone emerges as an unparalleled icon, drawing in countless visitors from across the nation and the world. Yet, amidst its captivating vistas and mesmerizing natural marvels, there's an alarming undercurrent that experts assert demands heightened scrutiny, a potential disturbance that could abruptly force the park's closure. But what exactly is this terrifying event? And how soon could it destroy the park? Let's find out. Spreading across 20 miles and measuring up to 1,200 feet in depth, the Grand Canyon is one of the most significant features of Yellowstone. The mere sight of this stunning canyon, coupled with the lower falls that pour down from an estimated height of 308 feet, it makes for a pleasant viewing that you perhaps wouldn't find anywhere else on Earth. The Mammoth Hot Springs is another feature of the park that cannot be ignored. With an astonishing combo of heat water minerals and limestone, the Mammoth Hot Springs is a geological phenomenon, much like the Geyser Basin, which is another astonishing gem within Yellowstone that's worthy of mention. According to reports, the Geyser Basin has more concentration of geothermal features than anywhere else around the park. Yellowstone is a ridiculously active geothermal area with over 10,000 hydrothermal features including geysers, hot springs, mud pots, fumaroles, and steam vents. Over the years, empirical evidence has proven that these geothermal features have overbearing similarities with dangerous real-life phenomena like volcanoes. And that's where things get really scary because the existence of these geothermal features could create other shocking and unpleasant features. For instance, within a period of 24 hours, a stunning 100 feet wide crack popped up out of nowhere in Teton. Confused by the quick turn of events and unable to come up with a viable explanation of how it came about, officials sealed off a large section of the park to carry out investigations. Not too much was revealed afterwards, but experts say they found expanding cracks around the rocks in the area and they'll investigate it further and look out for possible movements. Careful observation of this region is important because Yellowstone is believed to be currently recharging, meaning that its magma chambers are slowly getting filled up with molten rock from within the Earth's crust. And if they get filled to the brim, it could cause the landform on top to erupt sometime in the future. At the peak of its reaction, these chambers ruptured tend to release an incredible amount of magma into the atmosphere, which is sometimes equivalent to 240 cubic miles of rhyolite. Over the years, researchers have taken a keen interest in the plume of the magma, which is responsible for heating the rhyolite. Their main goal is to discover the exact amount of magma that's recharging the volcano each year. To achieve this, they added deuterium, a radioactive isotope, to different hot springs within the Yellowstone National Park. As the research proceeded, they calculated the amount of water and heat flowing out of the various hot springs in the park by taking measurements of the temperatures and monitoring the amount of time needed for deuterium to revert back to normal background radiation levels. And this has proven to be a good way to carry out the research without necessarily dealing with actual magma. From their findings, researchers discovered that their initial estimates were not accurate with the actual amount of water flowing through the springs. But in a more worrying discovery, researchers found that the intense heat emanating from Yellowstone's volcanic activity has transformed what was thought to be a dormant volcano into a looming threat. The simmering supervolcano, part of the Yellowstone hotspot, is poised to unleash a catastrophic Category 8 eruption, endangering the entire country. The hotspot is an immobile zone of volcanic intensity below the Earth's surface, responsible for the formation of the Yellowstone caldera and the park's geothermal attractions. Originating from a mantle plume, this hotspot has influenced the region's landscape by creating extinct volcanic centers as the North American tectonic plate drifted across it. Yellowstone's iconic geysers, hot springs, and mud pots owe their existence to the energy and material sourced from the magma chamber beneath the park, fueled by the hotspot. The hotspot's effects extend beyond the park, shaping the Snake River Plain and landmarks like the craters of the Moon National Monument. Over the course of its active years, the Yellowstone hotspot has witnessed varying intensity. Periods of volcanic activity, like the Yellowstone caldera-forming eruptions, are separated by longer quiet periods. Interestingly, this provides key insight into the Earth's mantle processes. However, recent ground rising and heightened geyser activity within the park sparks concern and raises questions about an imminent eruption. This has got scientists worrying as they search for possible innovative solutions. NASA, in its capacity, has proposed a solution that involves drilling into the supervolcano to cool it with high-pressure water. This sounds like a plan that could work, but it's not without risk. As a matter of fact, experts fear that the drilling process could trigger an eruption. Even if successful, complete cooling takes millennia, and as we mentioned earlier, success isn't guaranteed. Based on history and computer modeling, scientists predict dire consequences. A super eruption could bury the northern Rockies in 3 feet of ash, causing chaos in different states, including Wyoming, Idaho, Colorado, Montana, and Utah. Midwestern coasts would also suffer. Even a few inches of volcanic ash can devastate plant, animal, and human life. The aftermath of a massive volcanic eruption, like the kind that could potentially happen at Yellowstone, would result in unprecedented disaster. High-rise buildings would crumble, roads would become impassable, and even a small amount of volcanic ash would lead to widespread respiratory problems. Additionally, there would be disruptions to power lines, potential failures in transformers, and the halting of air travel all across North America. The global implications are truly remarkable. Such eruptions release substantial amounts of sulfur aerosols into the sky, essentially forming a protective shield that cools down the entire planet. These aerosols scatter sunlight in the upper atmosphere, lessening the amount of solar radiation that reaches the Earth's surface, which in turn creates a cooling effect for the whole world. For instance, the eruption of Mount Pinatubo in the Philippines back in 1991 emitted a significant quantity of sulfur dioxide that led to a global temperature drop of around 1 degree Celsius for several years. Similarly, the massive eruption of Mount Tambora in 1815 led to a notable cooling effect across the globe, causing the infamous year without a summer in 1816. This event brought about crop failures, triggering widespread food shortages and famines. In the unfortunate event of a super eruption occurring at Yellowstone, its impact would reverberate far beyond the immediate vicinity. The sulfur aerosols released into the atmosphere would disrupt normal weather patterns, affect agriculture, and pose threats to ecosystems on a global scale. Although the cooling effects of volcanic aerosols are temporary due to their relatively short lifespan in the atmosphere, their impact on the climate could be substantial and long-lasting, resulting in significant and enduring consequences. Renowned physicist Dr. Michio Kaku predicts that Yellowstone will erupt in 2023, a prediction he's maintained for over a decade. Despite this, he offers reassurance that we will receive advanced warnings, providing us with weeks to evacuate before the unlikely event unfolds. However, we must consider whether we've been neglecting the warnings we've already encountered. For example, the Steamboat Geyser erupted a record-breaking 32 times in 2018, hinting at underlying unrest. Similarly, other geysers, like the long-dormant Excelsior Geyser, have unpredictably erupted, unsettling the land with debris from past decades. Yellowstone's ground has been gradually rising, accompanied by over 121 earthquakes in a single December within the North Geyser Basin. Such signs highlight an escalating planetary instability, foreshadowing unprecedented natural disasters. Despite experts' attempts to reassure the public, Earth's trembling intensifies annually, signaling imminent and potentially deadly upheavals. Yet, adhering to Dr. Kaku's counsel, global researchers converge at the Yellowstone Volcano Observatory. Their collective mission is to proactively address the impending eruption. While escaping may become impossible, the observatory's efforts strive to mitigate the eruption's catastrophic impact. Scientists utilize an array of tools to monitor the Yellowstone caldera's activity, encompassing ground-based stations and satellite imagery. Among their pivotal instruments, seismometers detect the vibrations triggered by subterranean magma movement, offering insights into its trajectory and growth rate. Complementing seismic tracking, researchers closely monitor hot springs and geysers, whose combined activity poses the danger that defines Yellowstone. Another crucial focus at the observatory is the study of volcanic gases, such as sulfur dioxide, carbon dioxide, and water vapor. These emissions illuminate the composition and behavior of the underlying magma chamber. Leveraging advanced methods like remote sensing and gas sampling, scientists collect and analyze volcanic gas data park-wide, unveiling vital information about Yellowstone's dynamics. Navigating challenges and risks tied to the intricate Yellowstone caldera, the team remains dedicated to deepening our comprehension of this natural marvel. Technological advances in data analysis have yielded significant progress in understanding the system, even revealing the presence of a shallow magma reservoir beneath the park's surface. Collaborating with governmental entities, the scientists provide real-time monitoring and alerts during heightened volcanic activity, safeguarding the park's millions of annual visitors, and by extension, the planet itself.